Welcome back for today's class, dear children. Today we will discuss about electric flux. In the previous lessons, we have learned electric field. You know what is electric field? Okay. And electric fields we can visualize by means of electric field lines or lines of force. We have learned the definition for lines of force. What are electric field lines? It is the path traveled by an independent unit positive charge in an electric field if it is free to move. So surrounding any charge, there will be electric field lines because they exert force. So there is electric field lines. Now, this total number of field lines passing normally through an area is called electric flux. Okay, so electric flux. So electric field we consider it is flowing. That is why the word flux is coming. So what is electric flux? It is the total number of lines of force passing through a given surface, passing normally through a given surface. Okay. So if the magnitude of the charge will be more, there will be more field lines and there will be more flux also through an area. Now electric flux we can calculate. How will we calculate? We take the product of electric field and the area. Okay, that is how we calculate electric flux. So electric flux. So what is electric flux? It is a total number of electric field lines passing normally through a given surface. Electric flux is the total number of lines of force passing through a given surface. Passing normally through a given surface. So when you consider a point charge, you know, there are electric field lines like this, right? These are electric field lines. Okay, when you consider a small area here, what is the flux passing through this area? This area into electric field. How will you calculate it? We can calculate by multiplying area into electric field. So electric flux is total number of electric field lines passing normally through a given surface. Now I am drawing a surface. This is a surface. This is the electric field. A is the area. In this case, we calculate electric flux as the product of E into A. Okay, product of E into A, electric field into A. And electric flux we denote by the letter phi. You remember Greek letter phi. This is a symbol for electric flux. See here, electric field was normal or perpendicular to the area. In most of the cases, electric field may not be normal. So in that case, how will you calculate the electric flux? See, this is the area. Suppose electric field is in this direction. This is the normal. So there is an angle between them, theta. In this case, electric flux is, you have to take component of field along the field direction. What will be the component of field along the field direction, along the normal? You have to take component of electric field along the normal. That will be E cos theta. So in this case, E cos theta into area. Okay. So this is a general equation for electric flux. So phi can be written as, you know, A dot B we always express as AB cos theta, right? So we can use that dot product here. Phi equals E bar dot A bar. That will be EA cos theta. Here in this chapter, in now onwards, we consider area as a vector. See, A bar I have written, right? In 11th standard, we learned area as a scalar, right? But here we are finding some flow through an area. So we have to consider area as a vector. The direction of area vector is the outward normal. Okay. So suppose this is a surface. This outward normal is the area direction. Inward normal, you take negative area. Outward normal, you take positive area. It is the convention. Okay. So you remember here onwards in this chapter, we consider area as a vector. What is the direction of that area vector? Outward normal. Okay. So what is electric flux? It is the total number of lines of force passing through a given surface, normally passing normally through a given surface. What is the formula to calculate electric flux? E dot A or EA cos theta. What is theta? Angle between electric field and the area. So area is a vector. What is the direction of area? Outward normal, positive area. Inward normal, you take negative area. So what is the equation for flux? E dot A. So what is the magnitude of this? EA cos theta. Okay. Now we can see the different cases. If theta is 0, that means electric field and the normal area vector are in the same direction. Then flux will be EA cos 0. What is cos 0? 1. So E into A. Okay. This is case 1. Second case, case 2. If electric field and area are perpendicular, you take the area like this. This is the normal area vector direction. If the electric field is in this direction, this angle is 90 degree, right? So what will be the flux here? EA cos 90. So 0. So if the electric field is perpendicular to the area, flux through it is 0. No flux will be passing through it. So one more case we can write. Case 3. Theta 180 degree. So what will be phi? EA cos 180. So EA into -1. Flux will be negative. In this case, area is this way. Electric field will be this way. Okay. So this is about electric flux. So what is electric flux, dear children? What is electric flux? It is the total number of electric lines of force passing normally through a given surface. What is the formula for electric flux? E into A into cos theta. What is this theta? Angle between electric field and area vector. So what direction you give to area vector? Outward normal is the direction of outward normal is the positive area. If you take inward normal, that will be negative area. Okay. Now this electric flux is a scalar quantity. Another important point you have to remember. Electric flux is a scalar quantity. What is its SI unit? Electric flux is, you know, E into A, electric field. Electric field, what is the unit? Newton per coulomb. Area meter square. So what is its unit? Newton meter square per coulomb. We can, there is another unit called voltmeter. Another unit is voltmeter. Remember. So electric flux is a scalar quantity. What is its unit? Voltmeter. Okay. So electric flux depends on area and electric field, right? Now I will give a numerical for this. Consider a uniform electric field 3 into 10 raised to 3 I hat. Question. Consider a uniform electric field. E equals 3 into 10 raised to 3. Electric field value is given. E equals 3 into 10 raised to 3 I hat Newton per coulomb. Question A. What is the flux of the electric field? What is the flux of the electric field? Electric field through a square of side 10 centimeter. A square of side 10 centimeter. Through a square of 10 centimeter on a side whose plane is parallel to the plane is parallel to the YZ plane. YZ plane. Second question. What is the flux through the same square if the normal to the plane makes normal to the plane makes 60-degree angle with the x-axis. Okay, so you read and understand the question. See, consider a uniform electric field E 3 into 10 raised to 3 I hat. There is I hat is given. That means direction of electric field is along x direction. Okay, you have to find out the flux of this field through a square of side 10 centimeter on a side whose plane is parallel to the YZ plane. Okay, so I'm drawing the diagram here. You take this as x-axis, take this as y-axis, take this as z-axis. And direction of electric field is along x direction because it is given 3 into 10 raised to 3 I hat for x direction. So electric field is in this direction. Now you need to find the flux through a square of side 10 centimeter whose plane is parallel to the YZ plane. See, YZ plane is this one, right? So this is the square, right? YZ plane. When you consider area, what is the direction of this square area? Outward normal. That means in this direction. So this is area vector in this direction. So in this case, how will you find out the electric flux? So electric field and A are in the area are in same direction in this case, right? So what is the flux? EA cos 0. E is given as 3 into 10 raised to 3. Area 10 centimeter side. So area of the square will be 10 into 10 raised to minus 2. You convert it to meter square. So you will get the answer 3 into 10 raised to 3 into 100 into 10 raised to minus 4. What will be the answer? When you multiply, you get 30 Newton meter square per coulomb. Second question. What is the second question? Read it. What is the flux through the same square if the normal to the plane makes 60-degree with the x-axis? Normal to the plane makes an angle of 60-degree. So then here, what is an angle between normal and the electric field? Electric field is along x direction. Normal makes an angle 30-degree. So what is the electric flux? EA cos 60 will come, right? So E is how much? 3 into 10 raised to 3. Area 10 into 10 raised to minus 2 square. Cos 60 will be 1 by 2. So on calculation, you get 50 Newton meter square per coulomb. Okay. But if they ask like this, if the plane of the square makes angle 60 degree with the normal, with the x-axis. Plane of the, if the question is like this, if the plane of the coil makes an angle of 60 degree with the x-axis, then what will be the answer? Then theta you have to take 30 only. So you remember that. Okay. So theta is the angle between normal to the plane and the electric field. If the question is, if the plane of the angle, not normal to the plane, plane of the angle make an angle 60 degree with the x-axis, then theta you have to take as 30 degree. Okay. Okay, children. So today I am stopping the class. Watch it, share it, like it. Thank you for all of you.